Hello, this video presentation is about domain and range, new terms for us, and some new notation that we are going to use. First of all, let's talk about our notation. In the past, we said x was greater than or equal to 2, less than or equal to 7, for instance. Or we would say x is greater than 2 and less than or equal to 10. Sometimes we use greater than or less than, and sometimes we used with the equal sign. When we looked at on our graph, if we had 2 and 5, for instance, and we had an open circle and a closed circle, like this, then we said x is greater than 2 because it's not equal to 2, and less than or equal to 5 because the circle's filled in. Well, we have new notation for this that we're going to use. We're going to use it from now on, and you're going to use it next year in 11th grade. We're going to use parentheses and brackets, like this. Parentheses means not equal to. And the bracket is equal to. So what I'm going to do is I'm going to write a bunch of notation. I'm going to write it the old way and the new way. If we said x is greater than 2 and less than 5, we'd write that as 2, 5. Not an ordered pair, but it's an interval. X is between 2 and 5. Not equal to 2 because of this parenthesis, not equal to 5 because of that parenthesis. If I said 2 less than or equal to x less than 5, we'd use a bracket, and then we use a parenthesis. Bracket means I'm equal to 2, and the parenthesis means I'm not equal to 5, and all the numbers in between. If I said x is less than 3, the bigger number goes here, 3, and here we use an infinity symbol with a negative sign. Okay? Goes from negative infinity, it's not really a number, so we don't use the bracket, all the way up to 3, but not including 3. If I said x is greater than or equal to 5, 5, positive infinity, and then we would use the parenthesis. And lastly, if I said x is between 2 and 5, and including them, greater than or equal to 2, less than or equal to 5, I'd use bracket 2, 5, close the bracket. Again, the smaller number is first, and the bigger number is second, and it's all the numbers in between. The last thing we have to look at with interval notation is if I have x greater than 2, less than or equal to 5, or x is greater than or equal to 7, less than 10, for instance. If I graphed it, it would look like 2, 5, 7, 10, open circle, closed circle, closed circle, open circle, and it looks like this. The notation that we would use for this is parenthesis 2, comma, 5 bracket, bracket 7, comma, 10 with a parenthesis with a big capital U. This means the union. It joins the two sets. Joins the sets. Okay? We're going to be doing something using what's called domain and range, where you're going to be giving me intervals, and the way you're going to give me the answer is in this notation. All right, let's talk about domain and range now. All right, domain is all the x values, all possible x values, and the range all possible y values. So the domain of this function is, if you look here on my graph, the values used for x start at 1 and get bigger and bigger and bigger and bigger. The domain goes from, oops, that's not correct. The domain goes from 1 to infinity. If I look at every point on this graph, x is either 1 or some number bigger. For instance, this point right here should have been, I missed my graph a little bit, is 1, 2, 3, 4, 5. And 1, 2, 3, 4. It's the ordered pair 5, 4. X is bigger than 1. This one, the ordered pair is 1, 2. But if I go over here, there are no dots, there are no points. The domain goes from 1 to infinity. The range, which is all possible y values, starts at 2, and then they get bigger and bigger and bigger, forever and ever and ever. The range to infinity. All right, let's look at another one. All right, here, our domain is all real numbers. The graph keeps going up and up to the right and up. So x keeps getting larger. And over on this other side, because it's a parabola, it keeps getting smaller. The domain is all real numbers. So from negative infinity to positive infinity. The range starts here at 3. So it goes from 3 to infinity. All right? Very simple. It's the values that are used. All right, let's look at something that's a little cuter. All right, just like on the number line, this open circle means there's no point included there. All right, let's look at our domain. All right, number 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So at 13, negative 13, we have an open circle. My graph starts there and the x values get larger. So my domain, we start at negative 13, And we go dun, 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 to negative 5. But I jump up here and continue on. So even though there's a break in the y, at negative 5, negative 2, I have a point, and negative 6, 4, I have a point. It's continuous. Dun, 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 and at 1, 2, 3, 4, I jump again, and I continue, and this is an arrow. So it goes from negative infinity, negative 13, to infinity. The range, however, is broken up. 1, 2, 3, 4, 5, negative 6. My range starts at negative 6 and goes to negative 2. There's a solid dot at negative 2, so I use my bracket. And between negative 2 and positive 3, I have no dots, no y values at all. So I start again at positive 3, and I go up to 4, 5, 6, to positive 6, where I have a bracket because there's a dot. It's not supposed to go above the line there. And then I continue. See if I can move this over. Oh, can't, I'm at the end. I continue, union, and 3, 4, 5, 6, 7, 8, 9, 10. My range goes from 10, but it doesn't include 10, to infinity, because that's an arrow saying I'm going up forever and ever and ever, as far also going to the right for an ever and ever. All right, hopefully this makes a little bit of sense. We'll look at a few simple graphs and identify the domain and range, and we will use interval notation. All right, have a great day. This was kind of long, but you guys can handle it. Talk to you later.